Okay, good afternoon, ladies and gentlemen. Today is August 18th, 2022. I'd like to begin by recalling the formula to find the partial sum of a geometric sequence. So the formula to find the partial sum of a geometric sequence is given by S sub n is equal to the first term times the ratio 1 minus r to the n divided by 1 minus r. Let's do an example using a partial sum. We're going to do two examples. Example number 1. If I have this geometric sequence 5 times 2 to the n minus 1, and say that I would like to find the fourth partial sum of the geometric sequence 5 times 2 to the n minus 1. I need to find the first term. The first term is going to be pretty straightforward. And if you're ever confused or you don't know what the first term is, just write the first few terms out. That's going to be, or write the terms out. That's going to be tremendously helpful. So I will tell you that you could find this easy by just writing the first four terms out and adding them up. But we're going to use the formula, and we'll find out in a bit why we want to use the formula. But I want to find the first term. The first term is going to be 5. And I know for this particular geometric sequence, I think it's fairly obvious that r is equal to 2. And if I want to find the fourth partial sum, here n is equal to 4. So I have all the pieces that I'm going to plug into the formula, this formula here. So here I go. I'm going to plug these pieces into the formula. A sub 1 is going to be 5 times a quantity 1 minus 2 to the fourth over 1 minus 2. And we will do the arithmetic here. This is going to be fairly easy arithmetic. 1 minus 2 is negative 1, so this is going to be a negative 5. And I have 1 minus 2 to the fourth, I believe, is 16. True or false? True. And so I have negative 5 times, is it negative 15? Please make sure that you check my arithmetic. So the fourth partial sum looks like it's going to be 75. Okay, it's just a short way. So the formula to find the nth partial sum, if I find partial sums, usually I'm going to find like S sub 8, S sub 9, S sub 14. That way I don't have to write all these terms out and add them up. I can just use the formula. For this particular example, I could easily add the terms up and find out that it does indeed equal 75. And we'll just do that just for giggles. A sub 1 is 5. A sub 2 is 10. A sub 3 is 20, right? And a sub 4 is going to be 40. And if I did indeed add those up, it would equal 75. So that just verifies the formula. So let's do another example here. I'm going to go to another page. And again, I'm going to find a partial sum. I'm going to write my partial sum formula out just because. And I'm going to consider this geometric sequence. And let's, for giggles, find S sub 6. So I need, if I'm going to use the formula, I need the pieces of the puzzle that I'm going to put in. And so I'm going to need A sub 1, I'm going to need R, and I'm going to need N. I think A sub 1 is easy. A sub 1, Billy? You are correct. A sub 1 is going to be 3. Julie? R, you're right, Julie. R is 1/2. And Jamal, would you give me N? Well, N is obviously 6. So we're going to plug those pieces in the formula and find the 6th partial sum of the geometric sequence defined by 3 times 1/2 to the n minus 1. And here we go, putting them into the formula. A sub 1 is 3 times the ratio 1 minus 1/2 to the 6th power over 1 minus 1/2. Okie-dokie. And so I'm just going to use my calculator and actually figure out what this expression equals. And I notice that 1 minus 1/2 is 1/2. 3 divided by 1/2 is 6, times the quantity 1 minus 2 to the 6th power. 1 minus 2 to the 6th power happens to be 63 over 64. 2 to the 6 is 64. 64 over 64 minus 1 over 64 is 63 over 64 times 6 is 189 divided by 32. So that's the 6th partial sum of the geometric sequence defined by 3 times 1/2 to the n minus 1. So here is a deep question. Okay, so here's an important question. Yes, Linda, please. If I have some R between 0 and 1/2, dang, sorry. So this is a very important, deep question. Pause the video and let you think about it. I'm going to restrict my R now between 0 and 1, not 0 and 1/2 for those out there in video land. So before you answer this question, as n goes to infinity, what is S sub n? This is a very important question. Before I answer this statement, let's try to figure out what S sub n is if n goes to infinity. Pause that for you have never in your life heard what S sub n is or had any experience with S sub n as n goes to infinity, because S sub n is an infinite sum. It's an infinite sum. It's a sum of infinite terms. If n goes to infinity, I'm adding up infinite terms. as n goes to infinity, this sum is this. A sub 1 plus a sub 2 plus dot 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 plus a sub n, where n, I never get to a sub n because n goes to infinity. It's an infinite sum. Our human minds can't wrap our head around adding up infinite things. You've had a lot of experience with it, but not really. This is an infinite sum, also called a so down the road. So before I even go in there, what the heck is a series? The sum, an infinite sum of the terms of a sequence. That's what S sub n is. If n goes to infinity, we're talking about an infinite sum. What is an infinite sum? A series. What is a series? An infinite sum of the terms of a sequence. Bam. If you don't understand that, pack your books up, go to guidance and drop. See you, buddy. So now's my question. Now's my more important question is now where does, as n goes to infinity, where does S sub n go? Here's for a geometric. As n goes to infinity, where does that guy go? And keep in mind, r is between 0 and 1. Don't shout it out if you know it. And if you don't know it, Aaron, you need to pack your books up and drop because we talked about it. Math, well, you should know this. As if r is between 0 and 1 and n goes to infinity, where does S sub n go? Okay, since we were not able to answer this question, which the question is this, as n goes to infinity, keep in mind, if r is between 0 and 1, we were not able to answer this question, S sub n, which is the first term, 1 minus r to the n over 1 minus r. We were not able to answer where this goes as n goes to infinity. It goes to some place finite, special. So here's my question. I'm going to lead you to the answer. I'm going to bait the hook, if you will. Keep in mind, again, we have the condition that r is between 0 and 1. So then my question is, yes, Lucy, you are correct. If r is between 0 and 1 and then goes to infinity, r sub n goes to 0. And that's a property of exponential functions. Because the base, which is r, is less than 1, and it's going to keep getting smaller, so r sub n goes to 0. So then I'll ask you again this question. Where does S sub n go as n goes to infinity? Oscar? Yeah. Yes. True, because as n goes to infinity, if r is between 0 and 1, that goes to 0. So this guy right here is going to 0 out. So I simply have the first term times 1 over 1 minus r. And we can write this way. This is the way you're going to present it in a book. Huge. Yeah. It's huge. This formula is huge. It's huge. Example number 1. Example number 1. Example number 1. Or we could say, what's the infinite sum for the geometric series defined by 5 times 1/10 to the n minus 1, sorry. Sorry, Jamal. Bertha. Golly gee, what's the first term? The first term is equal to 5. What's R? 1/10. So it's going to be the first term over 1 minus 1/10. What's 1 minus 1/10? 9/10. So this is going to be 5 over 9/10. What's 5 over 9/10? I believe that's going to be, so the infinite sum is 59ths. Check this out. Here's a very important question. Is 59ths a rational number? Yes. Check this out, homeschoolers. Fifty-ninths is 5.55 repeating. Guess why this repeating decimal is a rational number? This is a huge. Jamal, please pay attention. Jamal. Betsy, put your daggone phone away. So my question to you, Betsy, is why is 50 over 9ths, why is a repeating decimal a rational number, Betsy? Because it can be written as a fraction. So here's my question to you. No, you're good, bro. So 0.77 repeating represents the infinite sum of what geometric sequence? Step 1. I'll write the steps out for you because I'm a nice guy. Write 0.77 as an expanded sum. Here we go. If I want to write this as an expanded sum, here I go. True or false? Isn't 0.77 repeating? Isn't that equal to 0.7 plus 0. What? 0.7 plus 0.007 plus ... So what I'm going to do now is I'm going to write that. I'm going to rewrite those decimals as fractions. 7/10 plus 7/100 plus 7,000 plus ... True or false? This is these are the terms of a geometric sequence. Okay, what's the first? Before I talk about this, what's the common ratio between each of these terms? 1/10, right? 7/10 times 1/10 is 7/100 times 1/10 is 7,000. What's the first term? 7/10. So here, a sub 1 is equal to 7/10, and r, the common ratio, is 1/10. So if I want to write that as a geometric sequence, what would the geometric sequence be? It's going to be the first term times the common ratio n minus 1. True or false? That's the geometric sequence. So tell me then, what is the infinite sum of this geometric sequence? I already have the values that I need. I need the first term, which is 7/10, and I need the r, which is 1/10. So this is going to be 7/10. What's 1 minus 1/10? 9/10. What in the world is 7/10 over 9/10? 7/9. Guess if I put 7/9 in the calculator, what are you going to get? 0.7 repeating.